Alright, welcome at this Chuck solution. So in this lesson we are going to be dealing with a vector cross product and a vector 2 here. So let's go here. Alright, so if we have two vectors that we have a and b, where vector a is equals to abc and vector b is equals to def here. So abc and def here are the x, y, z what components here. Alright, so the cross product here we are saying is given by a times b is equals to determinant of ijk. Then we take the first vector of a and place it in the second row here. So it's going to be a, b, c. Then we take the vector of b and place it in the third row here. So it's going to be d, e, f here. Then we can find the determinant of this one by expansion of the first row here. So we can find the determinant by expansion of the first row. So this is going to be a times b is equals to so if you have been watching the videos on matrices, we explain the concept of expansion of the first row here. So you can see what we are going to do here is to find the determinant by expansion of the first row here. So it's going to be I. Then we are left with the 2 by 2 matrix here, which is bc ef here. So it's I times the remaining elements here after closing the row of I and the column of I here. Then we go to the next one here. It's going to be minus j. Then you close the row of j and column of j here. Then it's going to be a, c, d, f here. Remember, it's minus j on j here, so it's minus j. Then plus we go for k. We close the row of k and the column of k here, so we are left with a, b, d, e here. So if you simplify this one, a times b will give you a new vector. Since I minus j and k here are not the actual value, so this will give you a new vector. So we are saying the cross product of two vectors a and b, given that a and b are non-parallel vectors, they give you a new vector. Alright, so let's see here how it looks like here. So the vector will be perpendicular to both a and b here. Right, so let's see how it looks like on the sketch here. Right, so you can see we have vector b and vector a here. So if I make the cross product of a and b here, I'm going to have a vector which is perpendicular to both vector a and vector b here. So as you can see, this is the vector. So the cross product of a and b will produce what we call a normal vector. So a normal vector will be perpendicular to a and also perpendicular to b. So that's one of the property of the cross product here. Alright, it will produce a vector perpendicular to vectors which are under the cross product here. So we can use this cross product to find areas of parallelograms and area of triangles. Right, so let's see here how it looks like here. Alright, so you can see we have vector a here and also vector b. So you can see vector a and vector b are two sides that we can have. So if we try to complete a parallelogram here, we can complete a parallelogram which is in this form with two sides here that are adjacent to each other here. So it's a, vector a and vector b, which are making two sides. So we can find the area of this parallelogram. So the area of this parallelogram is equals to the magnitude of a times b. Remember, when you multiply a and b under the cross product, will produce a new vector. So if you find the modulus of that vector, that will be the area of this parallelogram. Alright, so we can also find the area of the triangle. So if we take we cut this parallelogram from this corner to this other corner by this diagonal here, we are going to have another triangle on this side here. So this will be the triangle here. So you can find the area of this triangle. So to find this area of this triangle, is going to be half of the area of the parallelogram here. So it's half modulus of the cross product of a and what and b here. So that's how you find the area of the triangle. So what you just need here, you need two adjacent sides here which are making an angle here, and if they complete, the other side complete the triangle here, you can find the area of the what of the triangle by using half modulus of the cross product of the two vectors which are making the angle, or which are adjacent to each other here. All right, so this is what we can do here. So let's go to the example here that we have. All right, so the example is saying find the vector perpendicular to both A and B. So we need the vector which is perpendicular to A and what? And B. Then item 2, hence find the area of the parallelogram formed by two adjacent sides here, OA and OB. Alright, so let's go here. So it's very simple. So to find the vector perpendicular to A and B, we are going to perform the cross product here. So A times B is equals to determinant of I, J, and K here. Then we take the first vector A here. So we're going to take 2 minus 1, 1 here. You can even take the second one and place it in the first row here. Then you put the other one on the third row. There's no problem. You produce a vector, but it will be in the opposite direction only. Alright, so vector B here, you can see it's 3 minus 1, 0 here, because they are on the K component. We don't have the K component here. So now the next thing, we are going to find the determinant here. So this is going to give us this expression here. So you can see for I, we are closing the row of I and column of I here, closing the row of I and column of I. Then it's I times the remaining 2 by 2 matrix here. That we need to find the determinant. Then minus J here, we close the row of J and column of J. Then we are left with this one. Then we go for K here. This is the same thing again. This is 2 minus 1, 3 minus minus 1 here. So if we simplify here, we are going to have I, because the determinant here is going to be 1 here. So it's times I. Then for the second one here, the determinant is going to be minus 3 times minus J here. This will give us 3K. Then for the last one here, the determinant is also going to be 1, and you multiply with K. So that's a normal vector. So this is the normal vector, or the vector that is perpendicular to both A and what? And B here. Alright, so then we go to item 2 here, finding the area. So to find the area, this is the parallelogram that we have. So this is A and B, which are two adjacent sides, which is on the parallelogram. So now to find this area, we're just going to find the magnitude of this vector here. So area is equals to modulus of A times B here, so which is A times B under the cross product. So you can see that that's the answer was, this one was 1I, which is I, plus 3J plus K here. So if you find the magnitude of that vector here, this is going to give us the area here. So the area is going to be square root of 11, so which is root 11 units square. That's the area here. Alright, so let's go to the next example here. Alright, so now let's go to the next example here. So you can see the next example is saying find the area of the triangle ABC, given that A is this point and B is this point and C is this point. Alright, so let's see how it looks like on the diagram here. So we have points A, B, and C, which are making this triangle. Alright, so for us to find the area here, we just need two vectors which are making an angle, so, or two adjacent vectors here. So in this case, we can choose A, B, and what? And AC. Or you can also choose BC and what? And BA. Or you can choose CB and what? And CA. These are will be vectors that will be adjacent here. So in this case, we are going to be taking A. So you can take AB and vector AC here, because they are making two adjacent side here. So what we are going to do, we are going to find those vectors, then we perform the cross product, then we find the area here. So it's going to be very simple here. So finding AB, so AB is OB minus OA, so this is going to be vector B minus vector A here. This is going to give us minus 1, 4, minus 3. This is the vector AB. Alright, so another vector that we need here is AC. So we are going to find vector AC. So vector AC is OC minus OA here. So it's OC which is minus OA here. All right, so this is going to give us the vector 2, 3, 3 here. All right, so now we are going to find the cross product of AB times AC, which is going to give us a new vector. So half of the modulus of that new vector will be the area of this triangle here. So we are going to perform our cross product AB times AC here, which is equals to IJK here. Then we take our first vector AB, we place it on the first row. Then we take our second vector AC, then we place it on the third row here. So if we perform here by closing the by finding the determinant here, like so, we close the row of I here, so this is going to be this value. If you close the row and column of J here, this is going to be this value. If you close the row and column of K here, this is going to be this value here. All right, then we find the determinants here. So if we find the determinants, we are going to have 21I minus 3J minus 11K here. All right, so that's the vector which is perpendicular to both vector AB and AC here. So half modulus of this vector will be the area of the triangle here. So this is half a modulus of AB times AC here under the cross product here, which is equals to half of root 21 squared plus minus 3 squared plus minus 11 squared here. So this is going to give us half of root 571 units square. So that will be the area of this triangle ABC. All right, so let's go here. All right, so now we have question that we have here. So I would encourage you to practice these questions, and these are the solutions that we have. All right, so thank you for watching the video. If you meet any problem, kindly contact me on the phone number below, so that we can assist you with more lessons and any help that you might need, and any study materials that you might also need. Thank you. See you in the next lesson.